Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here with lesson number 30 on learning how to use your Raspberry Pi. What we did in lesson 29 is we learned how to read from the GPIO pins, and so we had in lesson 29 two simple buttons that we could detect whether the buttons were being pressed or not. What we want to do now is we want to kind of combine a lot of the things that we've learned in the first 29 lessons and create a simple circuit that will read something from the GPIO pins, then make decisions on what to do based on those reads, and then output something to other pins. So we're going to demonstrate this with two buttons, a left button and a right button. This is button 1 and this is button 2, and two LEDs. This is LED 1 and this is LED 2. Now what you can see is if I can read from a button, I can read from any number of different things. If I can turn an LED on or off, I can turn any number of different things on or off. And so what I want you to see is that this is a very powerful technique. If you learn the programming syntax and programming commands and how to control these pins, then you can do a wide variety of different things. So what you're going to want to do is you're going to want to get your gear out and hook this circuit up. You can see that I am using physical pin 6 as a ground. I'm creating a ground rail here, and then I'm using physical pin 8, 10, 12 as the left leg of this button, and then physical pin 16 as the left leg of this button. Then the control line on this LED is 18, physical pin 18, and then this is physical pin 22. If you need help in reviewing where kind of like what our physical pin layout is, that was in lesson 25. You can go to www.toptechboy.com, come over to the Raspberry Pi with Linux lessons, and then you will come down to lesson 25, and then you can see a nice big description of what all these pins do. This is when you do the physical pin layout. That's where you set up as a GPIO.board, or you can set things up over here in GPIO.bcm. We've shown you how to do that in all these lessons. We're going to continue to use our board layout, which basically uses the physical pins. Okay, now you get this hooked up, then we're going to need to write some code. And I think most of what we're going to do in this lesson, most of the stuff you already know, but we're going to just show you how to bring a lot of it together all at once. And so let me control X out of there. I've got to select it. Okay, so I am going to see, where am I? I'm going to go change directory to home. Now pwd, you can see that I'm in my /home/pi. If I do an ls, you can see that I created a folder called myPython. I'm going to go down into that folder. So I'm going to say change directory myPython, because as we start fooling around, I don't like to have to keep entering the path names to get to my program. Now I'm in my Python folder. Now I can just create my file. So let's call this, let's see, nano, what do we want to control? What do we want to call this? Button LED, like that, button.led, button LED, and then .py, because all of our Python programs we like to keep organized with the .py suffix. Okay, so boom, we are now in a brand new empty file ready to write some code. All right, in controlling these buttons and seeing if you are up or down in the buttons and reading from these buttons, you really need to put some delays in there that helps debounce the button. And so I'm going to import from time, I'm going to import sleep. Okay, the reason for doing it this way is that way if I want to delay, I can just say sleep, and then in parentheses in seconds how long I want to sleep. This is the best way to import it because it makes giving the commands the easiest. I'm going to need my library that allows me to work with the pins. Do you remember what that was called? That was called capital R, capital P, little I dot GPIO as GPIO, like that. Okay. Now GPIO dot set mode We use physical pin numbering. We want to use the physical pin configuration, which is the easiest one. How do we do that? You remember GPIO? What do we call it? We call it board, B-O-A-R-D. That gives us the physical pin configuration. Now I need to give some variables to my different pins. I like to name my pins rather than going in and using 11 or 14 or 17. I like to name them because then I'm sort of I have relevant variable names on the pins, and it helps me keep track of things. And so I'm going to say button 1, which was this button, was hooked to which pin? That was hooked to pin 16. Button 2 was hooked to what? Pin 12. All right. And then what do I have? I have LED 1, and that was hooked to pin 22. This is LED 1 over here. And then I have LED 2 is equal to 18. Okay, because LED 2 is hooked to 18. Make sure you get your resistors in there right. Remember to always use your current limiting resistors. And remember I gave you the diagram of how to hook that up. So that should not be a big surprise. All right, now this is the thing. The button pins are input pins. So I have to set those up. GPIO dot set up. And then what do I have? I have button 1 that I want to set up. You see now I just call it button 1 instead of saying 16, and it's easier and it's just kind of more readable. Okay. At toptechboy.com on this lesson I put the comments in. When I paste the code I put the comments, but I'm not going to slow you down with a lot of comments in as I'm going through this. Go and look at the code on toptechboy.com lesson 30 and you can see all the comments. As you're doing it, it's always a good idea to put comments in. So button 1 is going to be GPIO dot, what's it going to be? It's an input, so I put in because it's an input. And now, because we're doing buttons, we want to use that internal pull-up resistor. I explained that in lesson 29, so we go pull, up, down. That's the variable. What is it going to be equal to? GPIO dot PUD underscore up. That's like maybe pull-up device and then put it up. So I'm activating the pull-up resistor. Okay, I wonder, I'll just type it in. GPIO dot setup. What do we also need to set up? Button 2, and it is also GPIO dot in, comma, pull, up, down, equals GPIO dot pull up device, like that, underscore up. So we have got our 2 buttons set up. They're both set up as inputs, and we've activated the pull-up resistor. All right, we got to activate these 2 LEDs, so we're going to go GPIO dot setup. What would that be? LED 1. And what am I setting that up as? GPIO. What is it? Out. Okay, I'm just going to take that space out for good measure. And then GPIO dot set up, and then LED 2, comma, GPIO dot out. All right, so now all of my buttons are set up, or all of my pins are set up. The buttons are set up as inputs with pull-up resistors. The LEDs are set up as outputs. All right, now this is what you're going to have to think. The way I want this to work is if I press the left button, I want the LED to come on. If I press the left button again, I want it to come off. What does that mean? That means I have to keep track of whether the LED is already on or off. Because if it is off and the button's pressed, I turn it on. If it is on and the button is pressed, I turn it off. So what I do on button press depends on your present state. And so these are kind of like, these would be sort of like flags that you put so the program knows where it's at. You can look at it and see that the LED is on, but how does the program know that it's on? You have to set up these things, like I call it button state, BS1, button state 1. So that's kind of for the left button and the left LED. It's going to be equal to false, because when the program starts and you get to this point, the LED is off. And then how about button state 2? Button state 2 is equal to false as well. So what does this mean? The left LED is off and the right LED is off to start with. Now, What do I need? I'm just going to sit and loop forever. How do I do that? I do a while loop, and I just say while 1, because 1 is always 1. This will loop forever. Okay? Now if I say if, so now what do I want to see? I want to look, so now I'm just going to continue to go through this loop, and I'm looking for a button press. I'm seeing, was the left button pushed, was the right button pushed? So let's look and see if the left button is pushed. So how would I do that? I would read the left button. How do I do that? GPIO dot, what do I want to do? I'm going to input. Input from where? Button 1. Okay, so I'm going to look at button 1, and if it is equal to 0, that means it's pressed, right? Because when you press it, you short it out to ground. So when you press it, it goes to 0. So if I press it, this will read 0. Otherwise, normally it's sitting there reading 1. So if it's just sitting there and I'm not pressing it, it's reading a 1. When I press the button, all of a sudden it will read a 0. So if I get to this point, that means I have a button push. And so I'm just going to print button 1 was pressed. Okay? Because that is going to be just so I can kind of debug the software and see if it's seeing those button presses. Just kind of a debugging thing there. Now, what do I want to do if button 1 is pressed? Well, it depends on what state I'm in. So I've got to look at that flag for the button 1. If BS1 equal false, that means if the light is off, what do I want to do? I want to turn the light on. So what do I do? GPIO dot output, and then where am I? LED1. What do I want to do? I want to turn it on, so I say true. So I'm outputting a true to LED1. That will turn it on. Now it's on. What do I have to do? I have to tell BS1 that it's on. So I go here, BS1 is equal to true. Right? How did I end up in here? I ended up in here because BS1 was false. All right. But now when I turn the LED on, the LED is on, so I've got to tell it BS1 is true. Okay. Does this make sense? Now I need to rest a little sleep for about a half a second, 0.5. That'll give you a chance to press the button and then get your finger off the button. Press the button, get your finger off the button. If it's behaving, if you make this too small, it'll go on, off, on, off, on, off, on, off real quick. If you make it too long, the system is sluggish. For human interaction, I find a sleep of about 0.5 usually works. All right. So that is, if BS1 is false, that means the light was off. What do I want to do? Turn it on. Well, else, if it's not false, then it's true. That means that it's what? It's on. And so if it's on, what do I want to do? I want to turn it off. GPIO dot output, which one? LED1. What do I want to do? Turn it off. False. Okay. Now, I have turned it off. What do I need to do? I need to tell BS1 that it's off. So now BS1 is equal to false because I turned it off. That way when I come back around on the next loop, I know, is the light on or is it off? And that way if it sees a button press, it knows to do the opposite. I hope this makes sense. All right. Now, what else do I want to do? Well, I got to look at that other button. So I say if GPIO dot input of what? Button 2. Okay. If it's equal to 0, what does that mean? That means the button was pressed. So what do? I say print. And what do I print? Button 2 was pressed. Okay. Now, when I press button 2, what do I want to do? Well, it depends on whether the light's on or off. If the light is off, I want to turn it on. If the light is on, I want to turn it off. So what do I need to look at? I need to look at this BS2 flag. It started out as false because the light started off false. So if I press it, then I want to look. If BS2 equals equals equals. That's the biggest mistake when I work with students is they try to do a conditional and don't put equals equals. So I am embarrassed when I make that mistake. So if BS2 is equal to false, if it's off, what do I want to do? Well, GPIO dot output LED2. What am I going to do to LED2? I'm going to turn it on. So I make it a true. And output a true will turn it on. Now what do I need to do? What do I need to do now? I need to tell it BS2 is now equal to true because I turned it on. Now what do I need to do? I need to sleep 0.5. And I needed another sleep up here, I think, that I did not put in, yeah. Right, so that way if I turn it off, it relaxes if I turn it on. So I put these delays in just so the button doesn't go crazy. Okay, it also helps debounce the switch. Okay, so that's if BS2 is false, I do this. Else would be it's not false, so it's true. So if it's true, what do I want to do? GPIO dot output. I want to take LED2 and I want to do what? I want to turn it off. If I turn it off, I better remember what? Tell BS2 that it's off, F-A-L-S-E, okay? And now I do a sleep of 0.5. Okay. You all are probably sitting there yelling and screaming as you have watched me make all types of typos, but I'm going to Control O. Remember we called this button LED.py, and then I'm going to enter, and then I'm going to do a Control X to get out of there, and then I'm going to say sudo. You have to run these as sudo because the normal Pi user does not have access to the GPIO pins. If you're going to manipulate the GPIO pins, you've got to run things as sudo, as super user. Super user do. Sudo. What program? Python. Which one? Button.led button. I'm sorry, no dot led.py. What is the chance this is going to work? There might be an error because I'm not cleaning up my GPIO right now. So if I get an error, let's not worry about that. Ooh, okay, so it didn't like those. Okay, but it's actually running. It was just saying I didn't clean up after the last time I played around with it. Lights are off. All eyes on the left LED. Look at that. One button press, it turned on. And look, I also got the thing button 1 was pressed. Now it should know that it's on, so if I press it again, what should it do? Turn it off. Look at that, it turned it off. And you see it saw button 1 was pressed. So you see it's knowing to toggle between turn it on, if it's on, turn it off. If it's off, turn it on. If it's on, turn it off. And that's why we had to have that flag, that variable BS1 to keep track of that. We will try LED number 2. Look at that. It's on. It's off. It's on. It's off. If you press both buttons at the same time, it's probably not going to work because you're going to be in that delay, in that half-second delay. So the stipulation is it just works one button at a time. Look at that. Boom! Oh, right. So you can see that for the first time on the Raspberry Pi, we are getting input from some pins, and then we're affecting things with other pins. So reading from one set of pins, affecting another set of pins. And so this is really a big step forward. Kind of like after all this, we're finally getting back to the point that we can kind of do on the Raspberry Pi what we can do, what we could do before on the Arduino. A lot of this stuff is a lot easier on the Arduino than it is on the Raspberry Pi. But you reach the point that you're either out of memory on the Arduino, or you need to get in and start doing some graphics or some more sophisticated file manipulation. You know, Python is really good at parsing strings and things like that. So you reach the point that you need more power, the power of Python, so you go to the Raspberry Pi. But then what you find is it takes a little bit more work to get these pins going. But hopefully now you can see how to read from things, you can see how to write to things, and you're sort of back to the point of what you could do on the Arduino. Okay, this is Paul McWhorter with TopTechBoy.com. Tune in shortly. We'll probably do one more LED and button exercise, and then we will be moving on to some new and exciting stuff on the Raspberry Pi. Paul McWhorter, TopTechBoy.com. If you like this, think about giving us a thumbs up. Maybe share this with other people, your social media, your Facebook, your Google Plus, Circles, all that stuff. Maybe give us a little visibility here for these lessons. Comment, give us some feedback. Is anybody even out there watching these things? Okay, I will talk to you guys later.